right, here's the Howa 1500 short action, all trued up real good. So anything shiny, bare steel you see is what's been trued, blueprinted, whatever you want to call it. Several names for the same thing, basically. So let's see if we can get into see both sides of the threads. So since the thread is a V, you want to make sure you get both sides of that V completely trued up. The relief cut here has been opened up to the new major diameter, and the bolt here has also been trued. As always, we start with the sleeve. We get that sleeve installed and then turned down. Then we proceed to go hit the backs of the lugs. Get the backs of the lugs trued up in the same setup. We don't take anything out of the machine until all the work is completed. Then, once the backs of the lugs are trued, we keep the center in the firing pin hole and then install a steady rest. Get the steady rest bearing points secured so that there's no play or anything in the bolt. We'll pull away the live center, which gives us access to the face of the bolt and all those features. So again, just like with the action, all the shiny bare steel is the portions that have been trued. So the face, the nose, and the fronts of the lugs. It's fitting real nice in there. The sleeve is taking up any slop that's in the back side there. So now there's no wiggling. So you can hear that. And then with the sleeve in, nothing. We have maintained, there's still clearance here. So that bolt, there's a little wiggle back and forth is what we want, but we do not want to be hitting this tiny little gap here, which the main important part is primary extraction. Right here on this inclined plane. So we have not messed with any of that primary extraction. You know, a lot of times if you get a little too ambitious and cut too much material, your bolt will be bearing here, which will give you a false headspace reading, and you're going to be losing quite a bit of that primary extraction. So you're going to have to rework a bunch of these features, building up a weld or whatnot, you know, on these surfaces to regain that extraction. So you got to be careful when you're doing this kind of work. And then the sleeve, the rear bearing surface of the Bolt Bowl Raceway, the bushing we used was a 688, and the bolt itself before sleeving was 681.5. You know, so that's 7 thousandths of clearance, 6.5, 7 thousandths. So now our bushing on the important surfaces here, 687. So we have 1 thousandths of clearance in there for proper operation and no biting. All right, here we are at the Grizzly G0509G professional gunsmithing lathe. I just thought real quick I would go ahead and video record how I get these Howa barrels off. This is by far the better method. It's going to destroy the barrel, but who cares? It's a piece of crap factory robot-made barrel made overseas that by a company that probably doesn't put the most quality and care into the barrel manufacturing. So we're going to get that off. So hang out with me while we machine this barrel. A little cutting fluid there. And we're going to come in real slow with this parting tool. Manual feed. We're basically just cutting underneath the minor diameter of this thread, which is like 935 or something like that. Got the carriage locked, the compound rest locked, everything is very rigid, locked, 4-jaw chuck with the barrel. And I did center it. So yeah, these barrels, as I mentioned, are just so dang tight. Okay, so action wrench, radius here for the top of the action, and then I've got a cutout for the recoil lug. Big beefy wrench. Yep, see how easy that is? Broke it loose. Very, very minimal effort. That way we're not, like I said, we're not stressing out the action. The other way you could do it is clamp this in a big vise, the action itself, and then take like a pipe wrench to the barrel. These things are normally so tight. A lot of them have a thread locker in them. This one doesn't appear to be because, yeah, it's coming off real easy. But anyway, this is just the preferred way to do it. You know, you're never going to get this off with like a barrel wrench or a barrel vise, the two halves. I've tried sandpaper in between those and everything I could think of. What do they call that one stuff? Whatever that powder is. That's a joke. That never works either. So I still use the wrench, you know, obviously to be able to wrench it off, but I didn't even have to step on the brake for that. And now it's coming off by hand. So there you go. So yeah, this one does not have any thread locker in it. That's pretty surprising. That 6/8 Western I did was full of glue. We got the barrel off. We're ready to do the next step, which is going to be blueprinting all the trimming cuts. So we're going to get that all set up and ready in the jig. So we'll be back for that. We've got the Howa 1500 installed in the blueprinting jig and in the 4-jaw chuck. So I've already centered the jig in the chuck here. So that's all done. And I fitted the appropriate bushings in the bolt bore raceway for this particular receiver. And I've got a little bit different setup here. I find this, the phone camera actually picks this up a lot better. But obviously I've fitted the bushings and the indicating mandrel off camera. If you are really curious to see that, I've got that already documented. Just click on this video right here, or just type in Howa 1500 6/8 Western, something like that, blue accurizing 6/8 Western Howa 1500, something like that. But I'll put a little card here that you can click on to get to that video. Right, so I do want to show the centering because this is the clearest one I've been able to figure out how to do. So we're going to go ahead and center this as you watch. Just double check, make sure. So you can see here, I'll just throw this way out of alignment. Okay, so you know, I've got a half thousandths indicator on in the Brown and Sharp best test in here right now. And then we'll switch over to the 1/10,000ths, just so I can show you how we get these receivers running perfectly true in accordance to the center line of the bolt bore raceway, which is what we're getting off of the mandrel here. There are two bushings in the front and back bearing surfaces of the receiver. Those are precisely fit, so I've got a whole range of them. Find the two that fit the best as far as in terms of fit, so we don't want them rattling loose or dumping out loose, but we also don't want to force them in. So they're held in, it's a very slight press fit basically. Then we take this indicating mandrel and feed that in through the bushings, and they're all very, very, very close tolerances, and this is also somewhat of a press fit. So the mandrel here is certainly not going to dump out You know, it's held in by its own fit to the bushings. All I'm trying to say. So what we do here is we get this spinning, and we're looking for the high side and the low side, and we're going to kind of adjust appropriately. So the section right here that I have it sitting on is correlating to the round centering. So we're going to go ahead and center it with these set screws up front. And then when we move the indicator to this end, the further end on my right side here, the rear set screws back here will adjust the axial alignment, or the conical, right? So we look for the high side, and we're going to go ahead and push down on this screw, and so that we're pushing the front end of this receiver down. And see, we're very close now. So we'll just go ahead and get this close, and obviously I'm doing this with my fingies. So that's close enough. Now we'll check the back side. And in terms of backside, I meant the backside of the receiver. So we're obviously, it's kind of opposite here. Right, so this one is the opposite. We're looking for the low. So that's high, now that's the lowest. And so pushing down on this screw will actually tilt that whole receiver up in the conical. And we're going about half the distance. So we'll go to the low, turn it in about half. On the opposing screws till we get close like that. So that's coming out real good. Now we'll just check again, because that'll throw the front side out. And again, front side meaning the front of the receiver, the part where the barrel screws into, because that's where the bushing is riding or sitting. High side. Now we're going to go ahead and loosen this one and tighten loosen the bottom, tighten the top. High side, loosen, tighten. There we go. We're within a half thousandths there, and you see how it's shifted the back end out, back end of the receiver. So we're going to go to low, right there. Same thing, about half the distance. This is just like centering in a 4-jaw chuck, except you got two 4-jaw chucks, as it were, I don't know why I keep saying it that way, but maybe you probably understand what I'm trying to say. Okay, 10.5, back to the front. So now we've got the 1/10,000ths, and you can see we're spinning about 2 10,000ths up front. Run out. Just try to dial that in. Too much. That's okay, we're still kind of loose on the set screws. Okay. Very minor adjustments here. So there we go. That front side is now running dead true. Now let's check the back side of the receiver. And probably can't dial this one out. This is going to be, that's usually as close as we can get, within about 1/10 to 1/2 of a tenth of a thousandth. I mean, we're talking such a tiny, tiny little amount that doesn't really even matter. So at this point, we're just going to make sure everything's snug down. Yeah, the screws feel pretty good in terms of torque or tightness. You can see I'm knocking it out already by just doing this. So yeah, I went a little too far there, but that's okay. Go low. Now we're getting a little on the tight side, so I'm going to start relaxing these screws a little bit, because we'll never get this indicator out, indicator bar, mandrel. So there you go. That's the way we do it here. 1/10,000ths. So spinning true. spinning true both in the axial and the centered, aligned, centered, and axial, conical. It's all dialed in now, running perfectly true to within 1/10,000th. And about a half there. So that's close enough for the video. I'll probably go around. I'll let the machine warm up, spin up a little bit, and make sure, double check all that stuff. But that's it's pretty clear there. This is going to be conversion from 308 Winchester to 6.5 Creedmoor. So there's not really conversion other than the barrels just changed out. So this is just a standard short action Howa 1500 that we're going to be truing up here in a little bit. So we're going to be cutting the threads, the face, and the lug abutments, truing those up within in correspondence now to the new center line. So hey, while we're at it, let's go ahead and check something. Let's check the run out. So there's the face. So yeah, we're about 2/1000ths out on the face there. So 2/1000ths out. And then, oh doggy, look at that. Still in focus, yes. So, wow. There's a ton of run out in there. So I'm just touching off on the relief cut in the right before the threads on this one. And so 10, 20, 30, 40, oh my God. 9/1000ths. That's pretty typical of the Howas. That's the last one I did was 9.5/1000-ish. So a full turn of this, make sure I'm right here, 40, 50, 60, 70, 80, yeah. No, 90. Okay, 8/1000ths. Yeah, so we're gonna be tuning this up. You'll so you can see what the benefit is here. So now, I guess just while we're still rolling, there's no trickery here. Not about tricking anyone. I'm an honest guy. We'll go back, make sure this is still spinning true. Yep. Still spinning true within a 0.5/10,000ths. Yep, that's still on camera. Awesome. Still in frame. So there you go. I don't know how much more clear I can make it. I solemnly swear that there's no trickery involved here or fancy video editing. This is, I'm not smart enough to do that. So anyway, there we go. That's what, we're almost 20 minutes of talking about this. So there we go. That is, this Howa 1500 is now spinning true, ready to be trued up, blueprinted, whatever you want to call it. So I guess we'll be back with some footage of that. Okay, here we are. I have just completed machining all 3 surfaces on this receiver. And so I'm going to show you the run out now, post machining. You saw before we had about 9/1000ths on the a relief groove. So here's my poopy toss 1/10,000ths indicator. And you're going to see a little deflection, right? So the relief was cut for the original barrel, which had a diameter of 26 millimeters, which is approximately 1.024. We have remachined the thread, single point cutting, so we are cutting material away, right? Which is making that bigger, the internal diameter bigger, which means that cutter was starting to drag, maybe not drag, but it was cutting grooves into that existing relief groove, if that makes sense. Because the relief groove was only relief for the original barrel, which is 1.024, 26 millimeters. So it measured about 1.025, something like that. A little bit of clearance, but we've gone to 1.050, something like that. So that threader, as it was cutting deeper and deeper, clearing out material, truing it up, started to cut into that. So what you're seeing there, and I've actually machined that out too, but that 1 to 2 tenths, which is kind of erratic, is both, you know, we're single point machine, so it's not a surface ground finish. So you got to understand that it's not going to be absolutely zero due to those reasons. So I've cut out that groove, but metal has a tendency to, even though the cut is gone, it's still stressed in that area, if that makes any sense, hopefully. And I don't want to cut out more than I need to. I don't think I even need to make excuses here, but there'll be naysayers in the comments. So and they don't even bother watching the video to see these kind of explanations anyway. So that's all I'm saying. We're seeing a couple tenths there due to those reasons, right? Heck of a lot better than 9/1000ths, right? Which would be 90 tenths, right? So the dial previously, I'll probably put like a before and after on here, but the dial was swinging almost entire travel of that dial. Now it's hovering and tickling right around 1 to 2 tenths. It's not too shabby, right? Okay, so while we got you, we're gonna go to the face, which was 2/1000ths out, something like that. Okay, now we're gonna come up to the face, just touch off enough. Well, poop. That's why I left the cutter in there. We're gonna take another pass because that is not trued up. Okay, I'm back. I figured out what happened. My carbide insert was pretty much burned up. I've switched out to a brand new insert, so I'm going to take another pass off the face here. I did see a spark jump off, which usually doesn't mean anything good when you're machining stuff. So yeah, I'm going to take another pass off of this, and that should fix her up back to no run out. Okay, so we're just gonna do this one more time. Just make sure I'm making contact here. All right, there's that. I'm gonna lock this up. Try not to bump this camera. Okay, let's take a pass. Yeah. That is looking way better. It's actually cutting instead of just polishing. Lifting a chip is what I'm trying to say. We're going to take 1/1000ths. 1/1000ths. Yeah. So that had to have been it. That had to have been it. Yeah. that surface looks much better. So let's go ahead and retouch while I got you here. See if I can get this in there. Just to show. Hopefully no run out this time. Oh, we're locked up. Why isn't it moving? Okay, there we go. We've got it loaded. Just kick her into neutral. And same thing. There we go. So a couple tenths again, but like I said, this is not a surface ground finish. Yeah, about 2 tenths. Just like I saw on the machined surface of that relief. You know, so, you know, I'm not trying to hide here. This is honesty. You're not going to get absolute zero run out unless you have it surface ground, polished, kind of basically, which is extremely hard to do. What we're doing is single point cutting under power, a lathe. Again, this beats 2000s, right? Remember, the needle was going like 20 lines on this. Now it's going 2. Just being honest. There's no reason to lie about anything. We could edit this to make it look like it's, you know, I could go like, oh, look, I'm touched off. Look at that, the needle's 0. You know, and it looks like it is, you know, holy cow, look at that. I could even go, hey, let's load the needle up like 10,000s, just like that. And if you didn't know any better, you'd be like, holy cow. I'm not going to lie to you guys. I don't lie to my customers. I'm straight up, man. So that's what we're getting. Again, way better than 2000s, right? Okay. Anyway, thank you very much for watching. Just another thing that I thought might be interesting for people to see. So that's that. This is Geoff with Accurate Rifles and Restorations, Casper, Wyoming. Signing off. We'll see you later.